Chapter 7 Homework, 7-19. The polygons below are similar. The figure on the left was reduced to create the polygon on the right. So we have the original and we have the new. What is the scale factor? And find the lengths of the missing sides. Let's first find a corresponding side. Okay, the bottom of this figure, which is called a trapezoid, and the bottom of that figure are going to correspond. So I can set up a proportion, y divided by 12. Now that's going to be equal to another proportion. For example, this side of the trapezoid and that side of the original trapezoid, they correspond. So I can set up a proportion, new divided by original. Remember, you want to go new divided by original. All right, now these two proportions should be equal because of similarity. Since they're equal, we can use cross multiplication. 6 times y, that's 6y, equals 4 times 12, that's 48. Divide both sides by 6, and y is equal to 8. So I'll let you find x. One thing we do need to find is the scale factor. And the scale factor is 6 times what number gives me 4. To find the scale factor, all I need to do is divide a new side by its corresponding original side. So for example, 4 and 6 are corresponding, so 4 divided by 6 is 2/3. I can divide the top and bottom by 2. So the scale factor is 2/3. What does that tell me? 6 times 2/3 is 4. It also tells me 12 times 2/3 is y. Y was 8. So there's your scale factor. There's y. Make sure you find x. 7-20. The two triangles below are congruent. Write a congruent statement relating the triangles. Then, describe a sequence of transformation that maps one onto the other. Okay. So, since they are congruent, we need to write a congruent statement. Triangle something is congruent to triangle something else. If I start on the left triangle, if I say triangle ANH, then it's congruent to triangle. It needs to match. So since I started with A, I had to start with O. And from A, I went to N next. So that means from O, I need to go to E next. And then finish with J. Triangle ANH congruent to OEJ. Make sure you describe a sequence of transformations. Triangle ANH can be something onto triangle OEJ. That's going to be your second answer. So you need to reflect it, rotate it, translate it, whatever you need to do. Make sure you describe a sequence of transformations. That's what that means. 7-24. State the domain and range. Let's start with A. This is a discrete graph. It's dots. This is like a sequence. So the domain, I'm going to use the curly brackets. Domain. That's going to be all of the x values. So there's a dot at 0, 1, and 2. So those are my x values. Since they're dots, I can't say 0 through 2. That's not allowed. I have to list each x value individually. Same for the range. I have to list the y values of all the dots. This dot has a y value of 1. This dot has a y value of 0. This dot has a y value of -2. All right, C. Since these are connected, I need to list the domain from left to right. Now remember, domain on the left-hand side we have -1, -2. This axis goes all the way to -infinity. And if I keep going right, this is 0, 1, 2, 3, 4, 5, all the way to normal infinity. All right, so because I have an arrow going up and to the left, that means my graph is going to go starting at -infinity because of that arrow, and it's going to come towards the right, it's going to come to the right, it's going to come to the right. Now this graph is in pieces, but as you can see, at -1, the function is still defined. It just jumps down to this other piece, and it keeps going, all the way to 2. So the domain is -infinity to 2. And with notation, if you like, that's x is less than or equal to 2. Range, that's the list of the y values. Same deal here. We have -infinity at the bottom, all the way up to -2, -1, 0, 1, 2, then to positive infinity. So for my range, the lowest it goes is 2. It stops there because there's a dot. And all these y values get hit by our graph. At -1, we jump from the piece on the right to the piece on the left. So there's still a y value at -1. We're just working on this piece now. And it keeps going up because the arrow keeps going up forever. Range, -2 at the bottom, -2 to infinity. With notation, if you like, y is greater than or equal to -2. I say y here because I'm looking at the y-axis. 7-25. Label the triangles at the right with the following information. F is 25. The measure of angle F is 25 degrees. The measure of angle A is 73 degrees. Line segment BC has length 44 centimeters. And that's also the same as EF. Measure of angle C is 82. Measure of angle G, 82. Are they congruent? Yes or no? If so, describe a series of rigid transformations. All right. So let's find the missing angle measures first. Starting with this one, let's call it X. In a triangle, the angles add to 180. So X plus 82 plus 73, these should all add to 180. That's X plus 155 equals 180. So if I take away 155 from each side, X is 25. So the measure of angle B is equal to 25 degrees. Looking at the other triangle, this is 73, 82, 25. So since this is 82 and 25, by process of elimination, that should also be 73. So measure of angle A and measure of angle E, these are both 73 degrees. Now, are they congruent? We can't use a squared plus b squared equals c squared. That's out because this is not a right triangle. There's no 90-degree angle. So if you notice, 44 centimeters, it's in between the 73 and 25. For the other triangle, it's in between the 82 and 25, so they don't match. They are not congruent. The reason again is the corresponding sides are different. They're between different angles. So I'll let you explain. Why are they not congruent? If you rotate triangle ABC onto the other one, can you get everything to line up? Systems of equations. I'll do A and D. This one, we have the bottom equation solve for y, and the top equation not. So let's use substitution. So let's take the bottom equation and substitute it into the top one. So this is 6x minus 2 times whatever y is equal to. So that's 2 times 3x minus 2. And that should be equal to 10. So 6x minus 2y equals 10. 6x minus 2y equals 10. Distribute. And when you distribute, the negative sign distributes. Minus 6x plus 4. 6x minus 6x, that's a zero pair. Those cancel. And 4 is equal to 10, which is not true. So we have no solution. When the variable disappears and what's left over is false, no solution. Okay, D. If you look at D, the x's are stacked, the y's are stacked on top of each other. So that's usually the hint to use elimination. Alright, I want to eliminate the x's. So I'm going to multiply the bottom equation by 2, but that's not enough. It has to be negative 2. And we'll see why in a second. So the top equation stays the same. Bottom equation, let's distribute negative 2. So that's negative 2 times x. Negative 2 times negative 2y. And negative 2 times 1. Do you see why 2 had to be negative? Now when I add them together, 2x and negative 2x cancel. So that's why 2 had to be negative, so that they would cancel. Then we have 7y equals sign 7. So then you can divide both sides by 7 to get y equals 1. Then, taking y equals 1, plug it back into either original equation, such as 2x plus 3 times y equals 9. So if y is 1, that's 3 times 1. So that's 2x plus 3 equals 9. Take away 3 on both sides, you get 2x equals 6. (736). Here's our triangles. Let's make a flowchart. Hooray. Assume these are not drawn to scale, so don't trust the picture. All right. There's some information missing. But I can start with AB. The length of AB is 14 feet. That's given. And the length of EF is also 14 feet, which is given. Conclusion: line segment AB is congruent to line segment EF. And that is just the definition of congruence. The definition says if two line segments have the same length, then they are congruent. Okay, next, we know that angle C and angle D have the same measure. That's given. Whoops. So we have measure of angle C equals 39 degrees. And the measure of angle D is 39 degrees. That's also given. So what does that tell us? If these two angles have the same degree measure, therefore, draw your arrows down here. Conclusion is angle C congruent to angle D. And that's just by definition of congruence. Remember that says if two angles have the same degree measure, then they are congruent. All right, the last one's a little trickier because you notice that this has a missing degree measure. So we need to find that. So let's mark down what we have so far. We have that we've said that these two sides are congruent. We've said that angle C and angle D are congruent. So then the last thing I want to show is angle E and angle A are congruent. If I do that, check out what I have. These two angles are congruent. These two angles are congruent. And these two sides are congruent. That's AAS. All right. So how do I find this? So this flow chart is kind of getting sideways. All right. First of all, let me note that the measure of angle E is 1/16. That's given. Now I know angle A is going to be 1/16, but how do I know that? Angles in a triangle add to 180, right? So if this is x, x plus 25 plus 39 equals 180. Solving for x, I get 1/16. So what's this called? This is called the triangle sum theorem. All right, so measure of angle A. Let me get rid of these letters for now. The measure of angle A is 1/16, and the reason is triangle sum theorem. This one's not given, we had to find it, right? And so the way we found this angle was with the triangle angle sum theorem. Okay, definition of congruence. If two angles have the same degree measure, then they are congruent. All right, so as pointed out before, we now know that those two angles are the same, these two angles are the same, and these two sides are the same. And that forms AAS congruency condition. Whoops. Conclusion: triangle A, B, C is congruent to triangle. If I start at A, then I should start at E. B corresponds to F. So ABC, that's E, F, D. And we know they're congruent by the AAS congruency condition. So it's a little messy. I had to go crooked on that because of my screen size. But that's the whole flow chart. All right. What is DF? Okay, so I'll give you a tip and you can figure that one on your own. DF is this side of the triangle. So what side does it correspond to in the other triangle? Then that's DF. Tuesday. Let's look at the diagram. The smaller triangle is similar to the larger triangle. To analyze this, we need to draw this as two separate triangles. So there's the little triangle and the big one. The little triangle has side length x and 8, and the big triangle has a base of 8, and then this side is 10 and 8. So you add them together, it's 18 units long. 10 plus 8 is 18. Okay. Now we can call this original and this one new. It doesn't really tell us which one's new and original. And we don't have to calculate the scale factor. So that doesn't matter so much on this. So you can see that x corresponds to 8. So I'll set up a proportion, x over 8. Then we have, on the small triangle, 8 corresponds to 18. So I'll set up another proportion, 8 over 18, and we set them equal to each other. Notice that x and 8 came from the original triangle. Those should both be on top. And 8 and 18 that came from the new triangle. Those should both be on the bottom. Solve for x. Okay. Determine if the triangles are congruent. Complete the congruent statement, state the condition, determine a sequence of rigid transformation that maps one triangle onto the other. So I'm just going to do one of these. Let's see if I can pick the tricky one. They're all kind of tricky, so let me do A. Okay, ABC, triangle ABC, ABC. So A corresponds to itself, B corresponds to D, and then C also to itself. It's helpful to think of this as two separate triangles. When you break the triangles apart, whoops, then the sides that were shared are the same length. That's called the reflexive property. So that means that these two sides are the same. That's going to be an S. These two angles are the same. That's an A. And these two angles correspond to each other, so another pair of angles match. So we have angle, angle, side. Angle, angle, side. The side is not in between the two angles. All right. Lastly, let's determine a sequence of rigid transformation that maps one triangle onto the other. Triangle ABC can be reflected over a horizontal line onto triangle ADC. So to see that, if you drew a line right here, if you flip the triangles over this line, then they'll match up. Everything will line up. So ABC can be reflected. All right, try B and C on your own, same deal. Congruency condition, finish the congruency statement, then do the rigid transformation thing. 748. For A and B, write a recursive equation using correct notation. For C and D, write an explicit equation. So recursive, recursive, explicit, explicit. All right, if we're looking at A, this to me looks arithmetic. (108) plus 12 is 120. If I add 12 again, I'm at 132. Recursive means t of n plus 1 equals t of n plus 12. What does that mean? That means the next term is equal to what you have now plus 12. For a recursive equation, you also need to give the first term, which for us is 108. That's the first term in the list. So t of 1 equals 108. All right, B, 2 over 5th times 2 is equal to 4 over 5ths. 4 over 5ths times 2 is equal to, 4 times 2 is 8, so that's 8 over 5ths. So this is geometric. I'll let you write the equation on that one. Let's go over D, explicit. This looks pretty geometric. It shrinks by an inconsistent pattern. So to get the common ratio or multiplier, you take the second number and divide it by the first number. This tells you what to multiply by. So the multiplier is 0.2. So let's check. 117 times 0.2 is 23.4. 23.4 times 0.2 is 4.68. Alright, so we need an explicit equation. So that's going to be of the form t of n equals the starting value, or the zero term, times the multiplier raised to the power n. So we just need to find the zero term. So the first term is 117, the second term is 23.4. To go forward, I'll multiply by 0.2. That means to go backwards, I should divide by 0.2. (117) divided by 0.2 is 585. That's the zero term. Equation: 585 times 0.2 raised to the power n. Okay, look at the triangle at the right. Each part is a separate problem. So problem A. If D is 48, and F is 117, what is E? We'll call it X. We don't know what it is, but we do know that X plus 117 plus 48 has to add to 180. These three angles should always add to 180. That's the triangle sum theorem. X plus 165 is 180. So X is 15 degrees. That's pretty straightforward, just solving for X. Once you get it set up. Part B. Let me help you set this one up. Okay, angle D is 4x plus 2. Angle F is 7x minus 8. Ooh, that's E. F is down here. Excuse me. So F is 7x minus 8, and angle E is 4x plus 6. Alright, solve for x. So if we add angle D, which is 4x plus 2, plus angle E, which is 4x plus 6, plus angle F, which is 7x minus 8. If we add together these three angles, they should add to 180. Combining like terms, 4x, 4x, and 7x, that's 15x. 2, 6, negative 8, that's 0. X is 12. So we need to calculate the measure of angle D. The measure of angle D is 4x plus 2. That's just 4 times 12 plus 2. So that's 48 plus 2. The measure of angle D is 50 degrees. And that goes up here. So I did A, I did B. Make sure you also do C. 59. Okay, are they congruent? If they're congruent, make a flowchart. And if they're not congruent, why not? Alright, part A. We need to use a property of triangles called vertical angles. That says when these triangles make a bow tie looking thing. All right, sorry, zoomed in here so I have more room to work with. So the first two angles that are going to be congruent are E and A. Since they have tick marks, that tick marks mean they're congruent. That's given. Then we have tick marks on side CA, line segment CA, that's going to be congruent to line segment CE. It's also given because of the tick marks. Lastly, angle ACB, that's from the bottom triangle, ACB, so I'm talking about angle number 2 here. That's congruent to angle ACD. I have to use the 3-letter angle notation here. This is not a triangle. I'm not saying the triangles, I'm saying the angle. And the reason I do that is because the triangles are touching. The reason we knew those were congruent was the bow tie, vertical angles. Okay, given that we know these 3 facts, our conclusion is triangle CAB is congruent to triangle CED. And that's by ASA congruency condition. That's how you do a flowchart. All right. Next, let us do B. CBD. CBD. Is that going to be congruent to the other one? Well, let's check. CBD, we know this side matches. They're corresponding. These 2 angles are right. They're the same degree, therefore they are congruent. And also, these 2 angles are corresponding. AAS. That's going to work. So we say CBD is congruent to triangle EFG. CBD, so we had to say in that order EF and we end with G. Flowchart. Let's start with our 90-degree angles. We know that measure of angle F equals 90 degrees, and we know that the measure of angle D equals 90 degrees. That's given. That's also given. We also know that if 2 angles have the same degree measure, then angle F is congruent to angle D. That's definition of congruence. If they have the same degree, then they're congruent. Okay, the rest of this is a little easier. Now we have that EF and CB are congruent because of the tick mark. EF is congruent to CB. That's given. We also know that G and D, angle G is congruent to angle D, because each angle has a single tick mark. So these 3 things tell us that angle's congruent, that angle's congruent, that side's congruent. They tell us that triangle CBD is congruent to triangle EFG. And we know they're congruent because of AAS. (763). Solve for indicated variable. Let's look at C. Let's solve for R. I see a fraction, so we multiply by the denominator on both sides. That's going to be R times E over R equals R times I. On the left-hand side, R divided by R cancels, and I get E equals R times I. Now to solve this for R, we need to get R all by itself. So we need to undo this I. You can undo multiplication with division. So divide both sides by I, and R is equal to E divided by I. Alright, now let's do one of these fraction ones. Let's do D. Alright, I'm going to be strategic with D, and I have a fraction right here. Before I get rid of the fraction, I'm going to take away 2x from each side. So that's 1 over y equals 3 minus 2x. Alright, and now to solve for y, I have a fraction, so I'm going to multiply both sides by the denominator. On the left-hand side, y times 1 is just y over y, equals, on the right-hand side, I'm actually not going to distribute the y yet. I'm just going to make a note that this is 3 minus 2x, all of that times y. Y divided by y is 1. Alright, now to solve for y equals, I need to divide the right-hand side by 3 minus 2x. I can undo this times sign right here by dividing. So this whole thing turns into a giant 1. Any number divided by itself, any expression divided by the same expression is just 1. So y is 1 over 3 minus 2x. That one was a little tricky. Okay, Wednesday's homework. Tamika heard that the diagonals of a rhombus are perpendicular to each other. Let's test this out. Graph a rhombus with those vertices. A is 1, 4. B is 6, 6. C is 4, 1. And D is -1, -1. There's my rhombus. Okay, when it says the word diagonals, they're talking about these guys. If I connect the D to B, that's a diagonal. And if I connect A to C, opposite vertices, that's also a diagonal. So there's 2 diagonals, diagonal 1 and diagonal number 2. Now what they're saying is, are they perpendicular to each other? Is this a 90-degree angle? Question mark. Well, a rhombus has, let's answer the questions. A rhombus has 4 sides that are equal length. Is this a rhombus? How do we figure this out? Well, what is length AB? How long is this side? I can't just count it because it's crooked, but I can make a triangle. Make a little slope triangle. This side of the triangle has length 2. The top of the triangle, length 5. Now I have a 90-degree angle, and I can use a squared plus b squared equals c squared. Alright, a is 2. 2 squared plus b is 5. It's 5 squared. And c is actually AB. Two squared is 4 plus 5 squared is 25 equals AB squared. So AB squared equals 29. And if I take the square root on both sides, AB is equal to root 29. Alright, so let me get rid of some of this. I'm going to just focus on part A first. So this has length root 29. And that was AB. Now I need to check that all 4 sides have the same length. So let's file that one away. And let's work on the next side. The next side, let's say BC. We also need to find CD and DA. Alright, BC. I can't count how long it is, but I can draw a little triangle. and use the Pythagorean theorem, a squared plus b squared equals c squared. Alright, this side along the bottom has length 2. This is a 90-degree angle, which allows us to use this theorem. And this side has length 5. So that's going to be 2 squared plus 5 squared equals, my hypotenuse is actually BC. Do you notice this is the same setup as last time? 4 plus 25. So that's 29. So BC, because it's the same setup, we're going to get the same answer. Alright, you need to find CD and DA and make sure they are all same length. Alright, now let's write down the equations of the line in which the diagonals lie. So let's find the equation of AC. Alright, if you make a little slope triangle for AC, it has a rise of -3 and a run of 3. So slope for line AC is rise over run, which is -3 over 3, and that's -1. Alright, next we need to write the equation. Y equals mx plus b. We know our slope. We also know a point on the line is 4, 1. So that gives us an x and a y to plug in. So y is 1 equals m, the slope is -1, times x, which is 4, plus b. 1 equals -4 plus b. That tells us b is equal to 5. So for AC, the equation y equals -1x plus 5. Alright, now you get to do the same thing for BD, and it looks like the starting value is pretty easy. I guess I didn't need to do that whole equation. I could have just noticed that the slope is -1. It's going to hit the y-axis at 5. So B, C, get the slope, and then y equals something times x plus 0. I'll let you do part C on your own. Compare the slopes. What do you notice? And something to think about is, are they opposite, reciprocal? In other words, is one slope A over B and the other slope is -b over A? Okay, 791. We get to make another flow chart. Alright, let's work on B. Okay, right away I see I'm missing some angles here. So let's call this x, and 20 plus 112 plus x equals 180. Angles in a triangle add to 180. So 132 plus x equals 180. So x is equal to it's going to be 8, 4, x is 48. So right away, these two angles are going to match. Since they're not labeled, let me call this ABC, and then let me call this D, E, F. Alright. These two angles correspond to each other. Measure of angle F equals 48. Measure of angle C equals 48. F we knew from the start, that was given. But to get C, we had to calculate it. And we calculate it using triangle sum theorem. So if two angles have the same degree measure, then they are congruent. Angle F congruent to angle C. This is definition of congruence. Okay, next we need to pick out two other corresponding parts. So I see these two side lengths, FE which is 6 centimeters. And that corresponds to CB, which is also 6 centimeters. And so if two sides have the same length, they are congruent. So this was given, that it was 6. CB is 6 centimeters, that was also given. And then we conclude they are congruent. Line segment FE is congruent to line segment CB. Definition of congruence. Okay, last, angle A, angle D. These correspond to each other. They're the same degree measure. So how do we write that out? Let's go step by step. Measure of angle A equals 20 degrees. That's given. Measure of angle D equals 20 degrees. That's also given. Because they have the same degree measures, therefore, they are congruent. That's just definition of congruence. Alright, so what does that tell us? These angles correspond to each other. These sides correspond to each other. And these angles correspond to each other. So we have two angles, but the corresponding side is not in between. So that's AAS. Triangle ABC is congruent to triangle DEF. And that's by AAS congruence. So there's your flow chart. If you're looking at D, these are actually not congruent. Why? Well, look at our two angles that match. Here's the first angle that matches. Here's the second angle that matches. Notice on one triangle, it's an ASA triangle, the side's in the middle. So this is ASA. And then the other one is set up for AAS. The side is not in between the two angles. So you can write that in words. One triangle set up for ASA congruence. The other triangle is set up for AAS congruence. Since they don't match, the congruency conditions, they are not congruent. Alright, 7-100. Let's graph these points. A is 1, 1. B is 2, 3. C is 5, 3. And D is 4, 1. Alright, let's form the quadrilateral ABCD. Lori thinks this is a parallelogram. That means AD and BC have to be parallel. Slope of BC, think about slope, dude. Slope of this side, since it's flat, is 0. Slope of AD and I'm sorry, this is line segment BC, line segment AD. So the slope of line segment AD also flat, so the slope is 0. Think about slope dude. Since they have the same slope, they are parallel. Okay, now we need to check AB and CD. Slope of AB. This isn't flat. I need to draw a slope triangle. Okay, so from A to B, I go up 2 and over 1. So that's rise over run. The slope of AB is up 2 over 1. 2 divided by 1, that's just 2. Now let's check the slope of its opposite side, which is CD. These are called opposite sides because they're across from each other. Also rise over run. So from D, I have to go up 2 and over 1. So the slope is also 2 over 1. It's 2 since they have the same slope. They are parallel. Okay. All right, now we have one pair of opposite sides parallel, both pair of opposite sides parallel. So both opposite sides parallel. So our conclusion there, conclusion was it's a parallelogram. These two sides are parallel, those two sides are parallel, therefore parallelogram. Now note about notation here. So if I erase all of this and just have my 4 points, this is A, B, C, and D. To show two lines are parallel, you can draw a single arrow just like that. And these two sides are also parallel. Since the single arrow is already taken, we'll put a double arrow on those. So this means parallel. And you see that on two different lines. It's just notation for those two lines are parallel. Seven 104. Without graphing, which ones are parallel, which ones are perpendicular. So the idea is solve each one for y. There's the first one. We'll do a harder one. It's 5y. So for this one, take away the 15x. You want to add 15x to both sides. Sorry, add 15x. So that is 5y equals 15x, positive 15x minus 25. Then divide both sides by 5. Y equals 15 divided by 5 is 3, so that's 3x minus 25 divided by 5 is 5. These two guys are going to be parallel because they have the same slope. Slope is 3 on both of them, they're parallel. All right, so finish the rest of them. Let's go on to 106. We have the endpoints of a segment. Find the coordinates of the midpoints. So one endpoint is 5, 2, and the other endpoint is 11, 14. So to get the midpoint, here's my first point. Let's call that x1, y1. And this is x2, y2. We're going to need to take the average of the x coordinates, x1 plus x2 divided by 2. Then we're going to need to take the average of the y coordinates. That's y1 plus y2 divided by 2. So x1 plus x2, that's 11 plus 5 over 2. And then y1 plus y2, that's 14 plus 2 divided by 2. That's 16 over 2, 16 over 2. So the midpoint is 8, 8. That means if you go to the middle of the line, M, it has coordinates 8, 8. Make sure you do B. Last problem. I'll do A and D. Okay, A looks good, except I have to multiply the bottom equation by 2, and then I'll use elimination. So the top equation, let me keep that the same. Bottom equation, multiply everything by 2. 2x minus 2y equals 4. Alright, x plus 2x is 3x. These y's cancel. 3x equals 17 plus 4 is 21. Divide both sides by 3, and you've got there x is 7. So now if I go back to the original equation, x minus y equals 2, and I plug in 7. 7 minus what number is 2? It's 5, right? Well, if you want to find that out, let me add y to both sides. So 7 equals 2 plus y, and then take away 2. Y is 5. Alright, D. This one is kind of strange. So I'm going to get all the x's and y's on the one side and then use elimination. Okay, so for the top equation, I'm going to add 2x to each side. And I've got 4x plus y equals 5. For the bottom equation, I'm going to take away the 2x on each side. So that gives me x plus 2y equals 3y. Then if I take away 3y on both sides, I get x minus y equals 0. 2y minus 3y is negative y. And then this becomes 0. Okay, so now we're going to use elimination on these two equivalent equations. Let me stack them on top of each other. And you'll see that now that everything's set up, this is actually going to be pretty easy. We just add them right together. The y's cancel, and I get 5x equals 5 plus 0, which is 5. Then I divide both sides by 5, and x equals 1. Now I can pick either one of these equations. I'm going to go with this one because look, x minus y is 0. So if x is 1, then 1 minus what number is 0? 1, right? So y is 1. 1 minus 1 is 0, so therefore y is 1. So we have y is 1, x is 1. Answer is 1, 1.